If we have an equation in which the only variable appears inside a power function, we can call that, if we like, a power equation. Continuing the trend of naming equations after the kind of function our variable appears in. And like many equations, where our variable appears in some sort of function, we get it out of there by taking an inverse. The inverse of x to the p is just x to the 1 over p. So we take the reciprocal. And remember, with fractions, if f of x is x to the m over n, then f inverse is x to the n over m, taking the reciprocal of that fraction again. With that in mind, if our number n is even, that means we have an even root in our original equation, which we've already seen means we need to check for extraneous solutions. If m is even, that means that we have an even power in our original equation. And as we've already seen from that, remember when we define the even roots, we make this restriction where we take the positive even root. But the negative even root is still a solution to the equation. So when we get rid of an even power, we have two solutions where we use a plus or minus. When we're working with power functions, we're going to restrict ourselves to using real numbers, which means that we can't take even roots of negative numbers. At this point in our career, we will define this later on, but it gets complicated and we're going to avoid it for now. So what that means is, if we're solving one of these power equations and we find ourselves in a position where we would need to take an even root of a negative number, there's just no solution there. Now, in many real applications, especially when we've figured out the exponent based on some data, we're going to restrict ourselves to only talking about positive numbers, and we won't really need to worry about this plus or minus stuff. But in mathematics, we're going to pay attention to that because sometimes it makes a difference, and when it does make a difference, we get in big trouble if we ignore it. So, let's solve this equation, for example. So here we have a variable inside a function, and we're going to follow the usual drill. We're going to isolate it, then take an inverse. So let's see what we've got. We've got 3 times x minus 1 to the 2/3 equals 12. First, we want to get rid of that 3. So we're dividing by 3. We've got x minus 1 to the 2/3 equals 4. Okay, and now we're going to apply the inverse. The inverse of taking the 2/3 power is taking the 3/2 power. And then, since this is even, we need a plus or a minus. So 4 to the 3/2, we can do that on our calculator, or we can work it out by hand, whichever you prefer. It's 8. 4 to the 3/2 works out to 8. And finally, we add 1 to both sides. So our solutions, x is 1 plus 8 is 9, or 1 minus 8 is negative 7. And our denominator here is odd. So we are not at risk for extraneous solutions. We don't have to check. So we needed that plus or minus, that plus or minus, that plus or minus, because 2 is even. The number in that position was even. But we're at no risk for extraneous solutions because the 3, the number in that position, was odd. And that's all there is to solving these equations that involve power functions.